Hi there, this is a Redux to an episode I did in 2014 about the importance of processor die shrink. This is my 2021 edition. My name is Steve, and this is TQA Weekly. And today you're going to learn about the necessity of processor and transistor die shrink, as well as quantum tunneling and error detection and correction, as they become more and more important in our everyday lives. Some of you might not have known this or have never looked it up, but transistors inside of our processors have gone from 10 micrometers and bigger to 5 nanometers, and they will get smaller. And this means that the insulation in between each of these transistors is getting thinner and thinner, which is a problem because now we have to deal with quantum tunneling. Transistors are either open for 0 or closed for 1. And that means that each of those values is now in peril if the electron ever makes it across. And that means that we have to deal with erroneous information and command execution. So imagine for a second that you are an electron and you are flowing through the power lines. You head into a home and through a power supply where AC now becomes DC. Your voltage is dropped and now you're flowing through the traces on a motherboard into a processor. You head into a transistor gate. It is open. You are meant to be a 0 and you decide you're going to be a 1. I don't know why you have consciousness, but we don't know anything about any of these particles anyway. Now you make it across and you're supposed to be part of hexadecimal code and you're meant to be a C. The 4-digit in binary was supposed to be a 0. You have now made it a 1. It actually makes the C a G, which is not valid for hexadecimal, and it either crashes the application, the task, the operating system, and maybe the computer, depending on how it was deployed. That is a problem. And 20 years ago, if we wanted to correct that, and yes, the technology was there, that would have slowed the computer down. But with decades, we have shrunk processors and the related transistors in each of the processing cores. We went from 1 processing core to 2 processing cores to 4 processing cores to hyperthreading, which allowed us to emulate 8 processing cores. And we are now at hundreds of processing cores in each processor, being able to go from only several command executions per second to millions and billions of command and data executions per second, meaning that we are now able to error detect and correct in near real time. And it is occurring so fast that you're not even aware that a problem ever happened. But I also want to point out that you wouldn't be sent as a single piece of information into a processor. You'd be a string of data or commands with extraneous error detection information. As this would be submitted into the processor, it would actually go through the process of being executed and examined, and then error detection software would check to see if this extraneous information that they added was still correct. And if it isn't, it would reject it, reinitialize that command to be sent again, and then check it again until the information is accurate. If you are that electron and you jumped, making that 0 to a 1, your entire existence would become pointless and you would be thrown away, likely as heat. And what would end up happening is that more electrons would flow through the processor, meet up to this open transistor, and then actually execute a 0, meaning that the hexadecimal code in our example would be correct. The application and the command would be stable, the operating system wouldn't crash, and neither would the computer. Stability maintained. Error detection and correction is extremely important to computers as we are referring to these transistors being smaller and smaller and the information that we are now storing in our computers being more and more important. No longer do we have days where we can just simply print everything out, and even then, error detection and correction is very useful. It is very important that we continue evolving our code and evolving our hardware to match at the same time, because with the merger of both, we are able to make smaller and smaller processing cores that are more efficient, that take up less power, and because we can actually detect when something goes wrong, make everything more stable than it used to be. Computers used to blue screen all the time, and now we simply don't notice that something happened. Windows keeps it in background, and you never see a thing. And I hope that with all this, you understand the importance of processor die shrink, because without it, every time a problem would happen, you would know about it. Your computer would either crash or it would take a really long time to initiate any tasks. And for those wondering, error detection and correction is not limited to your processor. It's also limited, or actually extended over to your drives, RAM, and other devices inside of your computer, including your graphics card. Just about everything that has a chip has error detection and correction, meaning that all of your data is always scanned for validity, meaning that you are far more likely to save information now and it not be corrupted than before, where data corruption was a real issue. And I hope you learned something about that. And also, in the next few years, I'll have to do this again, because processor die size are going to shrink even more. And quantum tunneling is definitely going to be a real issue even more then. So, like this episode if you like it, dislike it if you didn't, share with those just think benefit from this, and don't forget to subscribe. And if you have any questions, comments, suggestions for topics, you can email me at ask@tqaweekly.com or go to my website, tqaweekly.com, where you can see the show notes on this episode, past others, find other ways of subscribing, and of course, use the contact form and email me directly. And if you want to see me play RPGs like The Witcher, Watch Dogs, or even Assassin's Creed, head over to twitch.tv/zaccess1981, where I play several times a week. Thank you for watching, and goodbye.